Thank you all and welcome to GroupBy 2021 event. This is 2 days event and it's free for everyone who really like to learn something on data, and it's by community and for community. So here we are strictly follow the code of conduct. So please, if you need more information, then let us know. Otherwise, these are the rules. Now I would like to welcome our speaker, which is a Dev Wentzel, who is working for Microsoft, who is very expert in a data side. He at the moment he working as a data MPC as architecture, and today's topic is you might not need a data warehouse anymore. So please welcome to Dev, and Dev stage is for you.
Okay, so my name is Dave Wentzel. Hopefully you can see my screen. I'm not going to put this PowerPoint into presentation mode, long story, but it causes my machine to crash. So there it is. So somebody already asked about the title. You might not need that data warehouse anymore. That is clickbait. You probably still need your data warehouse, but what I want to do is show you why you may want to change the focus of how you do data projects using some of the paradigms I'm going to talk about today. So what I'm going to talk about is essentially how to essentially look at data in a data lake, and then a little bit about what a lakehouse is, which is kind of a melding of a data lake and a data warehouse. And then specifically, we're going to look at like what the query patterns are against a data lake. And then hopefully you'll see that some of these tools that we have and some of these thought process more than anything else are enablers to thinking differently about data. So that's the key thing. Generally with these sessions like GroupBy, everybody wants to see code and they're more interested in looking at SQL queries and things like that. This session is going to be a little bit heavier on the PowerPoint, which for people that know me, I don't generally do any PowerPoint, but I need to do that because it's more about the thought process. I can go in here and show you data lakes and lakehouse models and how to query data using SQL Server against a data lake or using Transact SQL, but it's not going to matter if you don't understand why we're doing this. People will come away from it and say, oh, okay, that was cool. I'll never use that again. And I don't want you to think that way. So there's that. All the code that I have today is out in that GitHub repo. Again, when we get to the code section, it's all out there, but it's not just the code. You can actually rehydrate my entire data lake using the process in that GitHub repo. So if you've never seen a data lake or worked with one or anything like that, that repo will give you setup instructions that you can deploy it into your environment. And by the way, if you ever have problems deploying that, let me know, because, you know, I hate to say this, but it deploys for me, but I understand everybody's Azure environment's a little bit different as to what they have permissions with and things like that. So I'm always interested in how I can make it better. So feel free to contact me if you have, you know, if you run into any issues. And then that repo has everything. It's based on Azure Synapse, and specifically Synapse serverless is the key focus, which is how you query a data lake in an extremely cost-effective manner, which we'll talk about. So that's what that's for, but it also covers everything else that I use when we do hackathons and workshops with customers. So if you want to learn how to do ELT paradigms, using Transact SQL constructs over a data lake, I have all of that in there. So, you know, it's got quite a bit of information, probably days and days worth of stuff. And again, any feedback you have is important. So I do want to spend some time just talking through like why we're here and why these concepts kind of are important. If you want to interrupt, I think everybody can do that. You can do that. I'm not exactly sure that I can see like all the chat and everything, but you know, we'll figure it out as we go along. Somebody mentioned here in the Q&A, so we don't use Azure. Will this session do much good for me? The answer is yes. So in the PowerPoint deck, I don't really touch, I don't think I mentioned the words Azure or Synapse anywhere. It's just my implementation of these concepts then we'll do with Synapse. Actually, I have an entire version too that just uses Databricks. It's the exact same concepts, but I do it with Databricks. If you're an AWS person, it's conceptually, you'll get quite a bit of information, if you don't mind me bragging, out of this as well. So that's not a problem either. The reason I choose Synapse is because, honestly, this is something we don't talk about at Microsoft too much, but there's a feature of Synapse, and we don't even have a term for it, but I call it the Visual Data Lake Explorer. And there's nothing else, and I can say that in all sincerity, there's nothing else on the marketplace from any other vendor that does that. And it makes the entire process far easier to understand. So, all right, enough on that. Let's kind of jump into it here. I'll give you a little background about me. Please feel free to contact me. I'm kind of a data scientist, but I'm not the type of data scientist that you're probably familiar with, and I'll cover that in the next couple of slides. But I focus on data and analytics, essentially. I work for Microsoft, but I was the CTO of a consulting company, and I've gone out and done this for numerous customers. And I'll give you some of the thought patterns, again, through this that I use on data projects, which I guarantee you will be much different than how you do data projects today. I'm not saying my method is right or anything like that. It's just I want you to have a different feel for how to do a data project. So that's the primary thing. Okay, so I have an extreme disgust and borderline hatred for data warehouses. And throughout this, you're going to see why. And I think there may be a different approach that we can use. So what are problems with data in general within organizations? So I'm not going to read this to you, but what I hear, and I talk to customers from executive levels down to directors and boots on the ground data people for large companies. But generally we hear from IT that they have data, but they can't really do what they want to do with the data. That's the theme. So that's what IT hears. Mostly I'm interested in what business people talk about when they talk about problems they have doing data and analytics. Again, not going to read this to you, but this is what we hear. And there's a theme here, and you'll see the theme over and over. It's, I want to do what I want to do with my data, and I want to have control over my data. And the existing data structures and processes that IT uses today don't do that. And that's a key thing. So what I'm going to show you today is kind of how to get around some of that stuff by using these data lake type concepts. And then again, we'll go over the querying aspect of this towards the end. So you'll actually see some SQL Server code, which is again what everybody wants to see. Okay. Let's talk about what data warehouse projects have, or just data projects in general, forget about the warehouse, have looked like in the past in IT organizations. Actually, before we do that, this is my term here, but you've probably seen a graph, something like this. I can't draw or do, PowerPoint to save my life. So my PowerPoints are very horrible. I apologize for that. But you've probably seen something like this, and I call it an analytics maturity model. There's not a specific term for this, but I want to go over this with you. And then you don't need to answer this, but just think like, where am I on this journey? So what you'll see is as you move from the lower left to the upper right in this chart, the analytics become much more harder, but it also becomes much more valuable. Okay, so traditionally, I'm sure everybody attending right now, the company you work for, or if you're a consultant, the companies you consult for, you're doing something like descriptive analytics. So descriptive analytics can be summed up as what happened. So if you think about what descriptive analytics is, it's kind of like a SQL Server reporting services report. It's kind of tabular data. Maybe it gets emailed around, but it has a history of what happened and people can use that. It's also Power BI reports fall under descriptive, and most dashboards also fall under descriptive. If you use Tableau, that would be descriptive as well. Some people will say the next level higher is diagnostic. So diagnostic report is, why did this thing happen? It's really it's the same as descriptive. What the difference is at some point, if you think of it like from a Power BI dashboard or a Tableau dashboard perspective, as you do drill downs and drill throughs, you're getting down to the whys, and you're getting very transactional. And that's all diagnostic is. And that's kind of a new feature of tools probably within the last 12 years. So that's why I put it on the chart. Going up, this is what most people, most companies are doing today that have data scientists on staff. Okay, and that's predictive analytics. So it's what could happen. So if you're a data scientist, you already know, all about predictive analytics. But if you're not a data scientist, or you're an aspiring data scientist or something like that, essentially what you do with predictive analytics is you take past historical data, you figure out what the problem is that you're trying to model, and you use that data to figure out if there's patterns and correlations to that data that can predict something in the future. And then we use that historical data to make the prediction. Most companies are at this thing. So a simple prediction could be, can you forecast my quarterly sales out a year? That's a very simple use case. Or it can be very hands-on. If you're a manufacturing company, it could be, I want to look at IoT device data as it's coming down the line, and can I spot patterns that'll predict failure situations? Again, when I ask business people, they say, yep, we're trying to get to predictive, or we hired data scientists and we're at predictive. Honestly, I don't think most companies really want predictive. And that kind of goes contrary to what you'll hear a lot of times. What they really want is prescriptive analytics, right? And prescriptive analytics is, what do I do next? And I'll show you all kinds of examples of this, and we'll talk through examples. But something like, what do we do next? In the industry, they actually call this the next best action. You'll see it abbreviated NBA, or sometimes it's NBX for next best action. And the X being, it could, depending on what the use case is, the X means something different. So next best action is something like, imagine you're out on Amazon, you buy something and it says, people or customers like you also purchase the following. So that's a recommendation engine. Everybody's familiar with that. That's prescriptive. It's also predictive a little bit as well. But that's kind of the use case everybody thinks about when they think about prescriptive. But really, in the business world, prescriptive is, I'm trying to generate insights out of my data. And it may actually be historical, or it could be future driven. But I'll give you an example. I had a customer come to me and they said, we spent in our last marketing campaign, we spent $10 million on Facebook marketing. And we want to know, was that the right amount to spend? Should we have spent more, less? Did we get any return on investment out of that marketing campaign? If it worked, should we be investing in an Instagram marketing campaign? If so, how much should we spend? Those are interesting questions, okay? If you think about those style questions. So, if you have that data today, how would you answer those questions? It's very difficult. So when you look at something like descriptive analytics, what happened, the stuff at the lower left, we probably have a lot of analytics professionals and BI people on the phone. That kind of stuff is very formulaic, right? So if somebody says, hey, I want to see quarter over quarter or quarter to quarter sales, the first thing you do is ask the business person, define that for me. They define it, and then you go off and you code it, probably against the data in the data warehouse. But think about a problem like, did we get ROI on our Facebook campaign? Was it the right amount of money? Should we have spent more? Why should we have spent more? Should we be looking at Instagram or TikTok? Those are questions that I can't answer with a requirements document, if you think about it. And likely that data doesn't even exist in a data warehouse. And if you're thinking through it like most people do, they're like, I don't even know what data I would use to justify that kind of stuff. And right there is the answer. That's prescriptive analytics, okay? A lot of times those types of analytics, you don't want to put that stuff in a data warehouse, because how would you put it in the data warehouse, right? Do I need fact tables for that? What fact tables do I need for that? Like, how do I model my customers? Can I use the existing customer dimension? There's all kinds of questions about that. And what you'll find is you spend a lot of time putting the data into a data warehouse to answer simple yes and no questions. And prescriptive analytics is just that. So if I say, should we be spending more money on Facebook? The answer is, well, we got a positive ROI, so yes. So you did all that work simply. To do a yes no style answer or to generate a number. It's not a profitable endeavor to put that kind of data in a data warehouse. Next thing is, data warehouses aren't real good for that style of analytics either, because potentially the data comes from tons and tons of sources. And when we sit down and we do sessions with customers where we look at something like marketing campaign ROI, the data sets that we need, if we need to just do ETL on that data, even to put it into an ODS or just a SQL server, it would take months and months to do, and it's not profitable. I need the answers to these questions now or as soon as possible. So I need to figure out a way to move and shift the time to value to the left. So it's a shift left style thing. So this is prescriptive analytics. We're answering difficult questions. Here's another example for you, just real quickly. Some of you may be familiar with customer lifetime value calculations. There's an entire theory on how, essentially what your industry is, how you calculate customer lifetime value. But it's just, if I treat my customer well, how much money can I extract from their wallet over the course of my interactions with them over their lifetime as a customer? So a lot of times, again, we'll talk with customers and they'll say, okay, we want to build a customer lifetime value calculation. And what I do is I think like a data scientist and not as a BI engineer. And I'll say, instead of creating this requirements document, let's sit down and have a conversation on what you mean by customer lifetime value. What is it you're attempting to do? And we do these sessions with customers, and they're called design thinking. You can kind of roughly think of it as sprint planning, but it's really more than sprint planning. It's we actually do the work and we build a rapid prototype as fast as we can, which is sometimes just a matter of a couple of days. But what we do is we'll bring in business people from different departments in an organization and say, what does customer lifetime value mean to you? And we'll find that it means something different to every department. So you talk to a sales group and they'll say, all right, I need to determine my customer lifetime value so I can determine which of my customers I should be targeting. They're high value customers. I don't want to target low value. And then the marketing people say, well, wait a second, that's not what we use it for. Again, we want to use customer lifetime value to figure out if we're getting ROI from our marketing campaigns. And to do that, we need to be able to track the life cycle of the marketing campaign all the way back to the customer. Again, if you have a data warehouse, think about that for a second. Can you do that with your data warehouse today? Every customer I've ever talked to can't. So again, if I need to build a data warehouse to do that, that's going to take a lot of time. And I need the answer now. Okay. So quick question, Blythe asks, so prescriptive analytics is like having a data science be a business partner or consultant. Yes. So when we talk about data scientists, people think, oh, well, you're out there doing, convolutional neural networks and you're doing machine learning algorithms and you're doing a lot of Python and Jupyter. Not necessarily. A data scientist is more thinking differently about data and being able to have conversations about data with business people. The best data scientists know how to do that like the back of their hand. And that's a key thing. So we'll talk a little bit more about that. As data professionals, you're probably thinking that's not my role, but it is. And we'll talk through that in a little bit later when we actually look at doing the queries. Okay. All right. So I forget where I was, but if you look at product developers and they say, or you ask them, what do you want out of customer lifetime value? Just real quick, if I go back to salespeople, they say, hey, we want to target the high value customers. The product development team, they say, well, we want customer lifetime value instead to figure out which customers we actually want to churn because they're not profitable. Maybe they're using old versions of our products that, if we just didn't have to support them, we could actually do new development. If we have developers on the phone, you all know what that means. So those are the types of things we're doing. And again, everybody's going to have a different use case for that data. So the point is, if I stick the CLV calculation in a fact table somewhere, it might not be at the grain of detail that the actual individual departments want. They want to see their view of the data. Now, what we can do is put the raw inputs into the CLV calculation into the fact tables. That we can do. But again, I would posit to you that these types of things, maybe we don't care so much that they're in the data warehouse. So here's what I mean. The customer lifetime value, does it matter? Do I need to see that on a Power BI report? Possibly. Okay, if you need to see it on Power BI or Tableau, then it should go in the data warehouse, right? But if I want to see the customer lifetime value on my front end website, then I probably don't want it in my data warehouse. I want it somewhere else that, potentially my application, if it's an Angular application or something like that, I can display that, right? And let's look at it this way. Again, if I'm in product development, I need that integrated with my systems. If I'm marketing, I need that integrated, with my my marketing systems. If I'm sales, I need it in Salesforce, right? So the data warehouse is less about storing the data for those style use cases. This is where the data lake comes in. I can use the data lake to get the data that can do these calculations as fast as possible. The data lake allows me to put it out there without having to put a model over top of it. So basically facts and dims. And then it allows me to do analytics as fast as possible against that. And I'm going to show you all of that coming up. Okay. All right. So the title is You May Not Need That Data Warehouse. And I'm definitely cogent of the fact that most of you on the call are SQL Server professionals. So let's talk through how you guys do data projects today. And again, if you want, you can correct me and come off mute or put a comment in the chat, but this is more to get you to think a little bit. Generally, let's just take a canonical use case. Somebody comes to you and you already have a data warehouse at your company and they say, we need to add quarter over quarter sales to some reports. And we don't have that today. And let's just, for the sake of argument, say the underlying numerics don't exist in the data warehouse. So what do you do as a BI professional today? First thing you probably do is you say, all right, I need a requirements document, right? And the requirements document is going to be, for the business analyst, where is this data coming from? But it's also going to be things like, define what quarter sales means, give me a little formula, things like that. Once you have that, then generally a data modeler steps in and says, okay, based on that requirements document, I can grab out of that, we're going to need the following numeric data elements that we don't have today. And I think those should be stored in this fact table and that fact table and some other fact table. And then they're going to say, we have some attributional data that it looks like the business needs to do this calculation. And that attributional data goes in this dimension, that dimension, and another dimension. Okay. And then basically the next step is the data modeler goes, gives that to the DBA, they build the DDL for that. And now it goes to an ETL person. So an SSIS developer. The SSIS developer says, okay, looking at the requirements document, here's the source systems where this data comes from, if they even know, and sometimes they don't. But here's the source data, and I need to basically massage that data to get it into the facts and dims, and that's their job. They're marshaling data around or copying data around, okay? At that point, possibly you're doing data marts or cubes. It all depends on your environment. We'll leave that out of the question. And then essentially somebody, usually a Power BI or a Tableau developer, says, all right, I'm going to put this on the report, the quarter to quarter sales, or I'm going to do this visualization, and they get it done. Now, it's at that point that it goes back to the business analyst, and you puff out your chest and you say, hey, I got all this work done. Aren't you happy? And the business analyst says, well, I asked for this 3 months ago, right? Or think about it in your organization. How long does it take to do all of that work I just described? Okay, it probably takes in the order of weeks to months. Some organizations, it takes years to do simple things like that. And some of you are probably laughing, but you'd be surprised. But you've really only shown business value to the analyst when you show them the report. And we all know what happens. The analyst says, oh, yeah, you didn't apparently understand my requirement. That's not at all what I wanted. And now you're back to the drawing board. You go all the way back to gathering requirements and building the models and things like that. If that's not your company, not a problem. It's just what we see most often. And again, when we talk to business executives, it's that life cycle reason, which is why they're hesitant to fund data projects. So data projects, regardless if it's data warehouse or anything else, assuming it's just basic analytics, data projects have a high fail rate. And the reason, in my opinion, is you spend a lot of time doing requirements gathering, a lot of time modeling the data into the star schema, and then finally, a lot of time massaging the data into the ETL. Then you got to do all the other things like building the report. It's only at that point when you've shown value to the business analyst. It's a difficult model to justify, especially when we're trying to move and generate value quickly. So assuming you agree with everything I've just said there, as far as problems with data projects, what's the solution? Okay, so there's a different approach, and the data lake, and specifically this thing that we call the lakehouse model, is meant to overcome. And I call this data sandboxing, but officially in the industry, they call this process exploratory data analytics. Okay, it's very data science-like, and well, I'm not going to read all this stuff to you, but let's just look at what the life cycle is. So I went over a typical life cycle for a data project. In the previous slide. So let me work you through that same. I want to do quarter to quarter sales. How do I do that as a data scientist or as a person that isn't a traditional BI style developer? Okay, well, the first thing I do is I say, okay, you want quarter to quarter sales. First of all, I don't even know what that means, but I asked the business analyst, where does that data come from? And this is a problem we see a lot of times with what I termed on that previous slide, legacy data projects. We talk about data a lot, but we don't actually go out and look at data. So we say, if we had this data, here's how we'd stick it in the facts and DIMS. But then you talk to the ETL developer and they're like, I don't even know where to get this data, right? So the first thing we do is data acquisition. And honestly, data science projects, this is the number one reason why data science projects fail, is because we just can't get at the data we need, unfortunately. So think about, again, that example of Facebook versus Instagram marketing. Think about all of the data pieces that you need to measure something like that. It's potentially dozens of systems. Getting all that data, it's hard. So we start with data acquisition. So we ask the business analyst, where does this data come from? And you know how it is in a large corporation, they'll say, well, it comes from this JD Edwards system, and over here from Oracle Financials, we got a little SAP over here, there's some dynamics, so forth and so on. Whoa, okay, that's a lot, but we need to get that data. So what we do is, we go out and we say, okay, let's stop here. Let's go get that data. I don't want to talk about data until I see data. Okay, so use data, don't talk about data. So we do data acquisition, and sometimes this takes a while, right? So this is traditionally ELT. So we do the extract from the source system and we land it to the data lake. Okay, and why do we use a data lake? Okay, well, because data lakes don't care about schema. It'll let you throw whatever garbage data you want out there. And if you're an ETL developer, you all know this feeling, right? You get a source system and it sends you a lot of garbage, and you're trying to massage that garbage into SQL Server, and SQL Server has data typing, and you just wish you didn't have to do that. I just want to see some data, and I'll just ignore the garbage. Okay, data lakes don't care. Throw whatever you want at it. Now, I know a lot of you are probably saying, well, that's, garbage in, garbage out style data. Well, as a data scientist, let me disabuse you of that information. Source data is dirty when it comes in. You want to keep that source data. One thing data scientists do very well is they look at dirty data and try and figure out, why is it data? And is there signal in that noise to the dirty data? The last thing I want is an ETL developer or anybody cleaning the data, and I'm losing that signal within the noise. So dirty data is important. There's always reasons why data is dirty. And if we can figure that out, we can answer all kinds of interesting things as data scientists. So that's why it's so important to keep the data in the data lake where I don't care what's wrong with it, because there are people that will be able to find nuggets of gold out of that. All right, enough said. Data acquisition, we get the data and we stick it in the data lake. And I'll show you how we do that coming up here, okay? Then we take the data, and by the way, we're going until 1 o'clock, right? So we have another hour. Maybe somebody can just put that in the chat. I think we do. I just want to be cognizant of time. We take that data and we put it in the data lake as it is, data acquisition, okay? And there's specific ways we do data acquisition, but let's not go off on that tangent. What I find when I talk to customers is we can take ETL developers and show them how to do data acquisition very quickly and very profitably, okay? And when we do that, we find that ETL engineers or ELT engineers, they take to the methods very quickly. And, traditionally what might take, let's just say as an example, 2 weeks to acquire data from a source system, we can get that number down to 2 days. Just that's an example. And in fact, nowadays, simple things like ingesting Salesforce data into a database, or I'm sorry, into a data lake in real time, I can do that in 2 hours. So data acquisition is not as much of a problem today as it was just a few years ago. Okay, and the tooling's getting better, but it's really the thought processes more than anything that get better. Okay, enough on that. Once the data is in the data lake, then we start doing what in the industry is called exploratory data analytics. Okay, and I have those things sitting next to each other. So there's business understanding and exploratory data analytics. Why is that? Okay, here's the thing that probably a good number of you on the phone, if you're, a SQL Server guy or SQL Server person, I should say, you really, and we won't have time to go into a lot of detail on this today, but you would really enjoy doing exploratory data analytics with customers. It's a lot of fun, and it's something that data scientists, this is what we're trained to do. What it is again, this would be before COVID times, a little bit different now. But what we would do normally as when I was a consultant is I would say, okay, we have a business problem like quarter to quarter sales. And I would sit down right next to the business analyst, and we would do something akin to like pair programming. Okay. And so what I mean by that is I would have the business person tell me what they're trying to do. And then I would write the SQL code to do that. Okay, you don't have to use SQL. You can use Python. Again, what I'm going to show you today is how I do it with SQL, and I'm going to give you the SQL code. But you could use Python if you're a data scientist, or pretty much any tool as well. Again, SQL is what most people are going to understand. And instead of having that business analyst write the requirement document, we talk through what is this quarter to quarter sales thing? And they walk through the calculation. And what we do is we build the SQL code that's actually going to build that calculation. And how do we write SQL code against data that isn't in a database? Okay, well, you can write SQL code against a data lake, and a data lake is just a series of files. So we're writing code against files, and we're creating value out of those files that we just acquired through the data acquisition aspect. Okay, so now we're sitting there and we're building these calculations stepwise using SQL, and probably all of you have done stuff like that before. In SQL Server, you use a lot of temp tables. With the method I do, we never use temp tables, but we do build things in a manner that's very iterative. So we do small amounts of work, and we're constantly showing value. A lot of times we do this work in notebooks, like Jupyter notebooks. If you use Azure Data Studio as a SQL Server professional, there's Jupyter notebooks built in. They're great. And the reason Jupyter notebooks are so good is because I can put my thought processes as I build this quarter to quarter sales calculation with my business analyst sitting next to me. We can put our thought processes there in documentation as we do our SQL, okay? And we're building value, right? And if you've ever seen the Jupyter notebooks, you know that then you can show, the charts and the graphs. So now we have charts and graphs to prove our hypotheses that are right. And if at any point we come down and we say, ooh, we made a mistake somewhere in the calculation, we look a little bit higher in the Jupyter notebook and we make changes. So that's exploratory data analytics. You don't need to use Jupyter. Just SQL statements alone work really well. Here's the next thing. Probably a few of you on the call, you're very hard, well, probably all of you, frankly, are hardcore SQL Server developers, and transact SQL like the back of your hand. You know how to do window functions. You can join 30 tables together with left and right joins, and conditional joining with OR clauses. You're all good at that. Here's the thing, business analysts, we're not so good at that. So what you do with exploratory data analytics is you do things a little bit at a time. And this goes contrary to how SQL Server people are taught how to do things. We like to create one big query that does all of everything, the correlated subqueries, the derived tables, all that kind of stuff. But business analysts, we can't look at that. And data scientists, a lot of times can't either look at that and figure out what's going on in all that code. So with the exploratory data analytics and the SQL that I'm going to show you, we do things very small. We do very little use cases, and we build them up constantly. Okay, and we stick that data in something that's akin to a temp table, but it's not really a temp table, and we keep building it as we go down. And then what we'll find is we can reuse a lot of that code and that subsets of data without necessarily putting it into the temp table. So it's a slightly different paradigm shift, and I'll show you all that with code, trust me, but it's a lot of fun. And again, the reason we do it in small chunks is because we want the business analyst to understand, okay, now I did this, now I did that, now I did this. And then when we work through the problem, we can take a step back if we realize we made a mistake. Now, something like quarter to quarter sales, that's easy. We don't need to do all that in a Jupyter notebook and have conversations with the business analyst. That's a defined problem. But again, think about the harder prescriptive analytics problems that you run into, like I need to determine Facebook marketing campaign ROI. Whoa, okay, again, I'm going to have to think through the steps in the process. And then with the Jupyter notebook, or even just with the SQL code, if I do things in small chunks and I document them, now I can show that to an executive, and the executive can say, I see what you did there. I like your calculation, but did you think that maybe you should change this variable just a little bit when you're doing that Facebook calculation? And then you have the ability to say, yes, let me just change that line of code. Let me execute that line down, which is the benefit of doing things in Jupyter notebooks. And now I have all the new data, and I can build all the new charts and graphs right there within the notebook, and I don't need to basically shell out and use Power BI or Tableau. That's the benefit. Anyway, that entire process of building business value, that's exploratory data analytics. Now, I think you guys get the idea. I am going to show you code, but let's just take a step back. Let's assume you did all of that work, okay? And you found the nugget of gold at the end of the day. So in other words, you figured out the quarter to quarter sales number, right? And the business analyst says, you got it. You solved my problem. Think about what I just did there, okay? I started with data acquisition. Once I got the data acquired that I thought I need, I sit down and I do EDA, Exploratory Data Analytics, with my business analyst. And we're iterating, we're thinking through this stuff together, right? That might take a couple of days, okay? I don't know, doesn't matter, it depends on the use case. In a couple of days, I get to the aha moment. We found the nugget of gold. That's the calculation we need. Now, what I just described there, how quickly did I get to value? And remember, within the Jupyter notebooks, I can even do the charts and graphs. I don't even necessarily need to have a Power BI expert that can do that kind of stuff necessarily, right? At this point, I've shifted what was potentially, in that legacy thinking slide I had, what was potentially weeks and months long to a matter of days. And that's the benefit of doing things in the data lake. Okay, now here's the thing. You found the nugget of gold, right? Using the data that we had in the data lake, which is still not facts and dims, but we found the nugget of gold. Now we do this thing I call the evaluation phase. And this is where we start, we want to determine what's the right thing to do with this data now that we figured it out. Okay, if it's quarter to quarter sales, now we know the answer. Now the business analyst says, well, that's fine. All we really need to do is put that on a Power BI report. So now you say to yourself, well, the calculation runs pretty fast out of the data lake, and we just need to see it on this one Power BI report. Do I need to spend the time right now putting that, all of the, the numerical data into the facts and the attributional data into the DIMS? Maybe you don't. So this is the evaluation. And this is where you start to come to the realization, maybe the data I need to report off of doesn't even need to go to the data warehouse. Maybe I can keep it in the data lake and suck it into Power BI or Tableau once a night as I need it. And maybe I'm happy, right? And I don't need to do any data warehouse work whatsoever. That's an interesting concept. Or maybe you say the quarter to quarter sales calculation, I don't need it in my data warehouse, but I need to send it over so that it's visible in Salesforce, or I need it in Dynamics. So again, here I say, now I can take that data, right? I can automate it, and we'll talk about how to do that in a second. And I can send that data to wherever it needs to go, and it's sitting in those systems, okay? Or take that Facebook example. I'm doing Facebook ROI calculations. Should I be spending more or less on Facebook? Once I answer the question, yes, you should be spending a lot more. And here's how much based on the data we have that you should be spending. Well, I answered the question. Do I need that data in the data warehouse? Absolutely not. I don't even need that data at all anymore at this point, right? So you make the evaluation phase. And we find this with customers all the time. If they think in terms of where do I do the analytics in the data warehouse, the project becomes a month-long project. If they just worry about showing the business value, then we can figure out, once we've found the nugget of gold, let's do some analysis or an evaluation like I have here. Where does that data really need to go? And sometimes the answer is not what our customers initially thought it was, which is the knee-jerk reaction is all analytics come out of the data warehouse. So you get to this paradigm where, maybe I don't need that data warehouse. Okay, but let's assume for a second you do need it in the data warehouse, okay? So the quarter to quarter sales you want in the data warehouse. Now I get a data modeler, right? And normally what would the data modeler do in the legacy thinking slide I had? Well, they'd look at the requirements document, which by the way, we never did a requirements document here. See how we did that? We worked together and we never needed to do it. Okay. But normally, traditionally, the data modeler would look at the requirements document and kind of glean out of that. Here's the numeric data, here's the attributional data, it goes in the facts and dims. It's guesswork, right? And we've all been there. We model it, and then we determine, weeks to months later, that model's not right. It's wrong, or we're missing a lot of data. We didn't do any of that, right? Because again, we have this code, possibly in a Jupyter notebook, but it's SQL code, where we've rolled through the calculation to find the nugget of gold out of the data lake. We know exactly what data we need. We know all the numerics and all the attributional data. We know it because we have it in the end result. Now the data modeler just has to go through that code and figure out all of the new interesting data elements that we created sitting next to the business analyst in order to support that calculation. The exercise in modeling becomes a no-brainer. It becomes very easy, and we never have to go back and rework it. That's it, right? Now, one thing, notice on this circle here, we never do ETL. And you're probably thinking, well, that's kind of weird. Okay, well, we do kind of do ETL, but not traditional ETL. So what we do in this process is we do ELT, right? So we did the E and the L as part of data acquisition, but we never did the T, right? Why is that? Okay, well, because the T gets done at two different places. The T, which is the transform, is what actually, when I sit next to the business analyst, that's what we do, right? So in taking the raw data from the source systems, joining it and mashing it together, and coming up with whatever the aggregation is and the output, that whole process is the T logic, if you think about it. Now, it's in a rough state. Okay, it's in a state that I can do visualizations. So now we do it again as part of this modeling activity where we say, okay, well, you have all the calculations there, but those calculations assume it's out of the data lake. We need it into facts and dims or a star schema. So we need to change that a little bit. But basically, just think of it this way. The ETL effort is severely lessened. So we find that ETL developers, they're doing much less work as far as just copying data around. What they're really doing is going out there and doing much more profitable work, which is the operational aspect. So again, with this model, this lake house model or this data lake model, the operationalization, and what I mean by that is how can I reproduce this data, or how can I update the data on a daily basis, or even an hourly or real-time basis. What we're going to do with operationalization is whatever we did for data acquisition, how we acquired the data, we're going to automate that. That's step one. And then if you think about it, that SQL process where we actually made value or generated insights out of that data, that's what we're going to operationalize. And sometimes we can just take the raw SQL and we can say, run through this and run through it maybe every night or every hour, or even in real time. And it's going to do everything, that the business analyst and I sat down and we did together to generate the output. And it's really kind of interesting. You're just basically saying, take this SQL script, make it a stored proc and automate it. And we've all done that. That's sometimes what the ETL ends up being. Okay, so then we build our visualizations over here, okay, and we do data governance. That's always important, right? So a lot of times I find when we talk to customers, data governance is done early. So they talk about, well, before we can do anything with quarter over quarter sales or Facebook data, we need to figure out like what's the governance model going to be, who needs access to this data, all that kind of stuff. What we find is customers, when they think like a data scientist and they do this data sandboxing, the governance conversation shifts to the right. It becomes a much later thing. And what I mean by that is we want to say, don't worry about data governance until the project is going to be successful. So we know right here when we do exploratory data analytics and we find that nugget of gold with the analyst, we know at that point this project is profitable, right? Because we've answered a problem. So again, as part of the evaluation phase, we do the data governance and say, okay, who has access to this data? How are they going to get access to data? Things like that. So we shift the conversation. So we're into problem solving. Okay, this is the model I want you to think through, maybe on your next, data project. And hit me up on LinkedIn. We actually run these sessions for customers, these design thinking sessions and rapid prototyping. We're very good at it, and they are a lot of fun. And we don't try to do these sessions for customers to solve problems like Facebook marketing ROI calculations. We do it because we want customers to come out of this and say, hey, that was an interesting way of doing analytics. We think we can do this. Or sometimes it does happen, we'll have customers say, oof, man, this is kind of complicated. We're not ready for this. And that's fine too, but it's a good way to learn these things. And again, as data scientists, we're all about experimentation and learning. So I love to do these free of charge for customers because it helps me to learn as well. And then again, my role at Microsoft, I take this back and I say, this is what we need to think about in the future of how we want to do analytics, right? So for those of you listening, notice I don't use Azure Data Factory, right? So this is kind of part of the thought process is maybe our tooling needs to change as well to kind of support these interesting ways to do prescriptive analytics. All right, I don't want to belabor this too much more. This is what a typical data lake looks like. If you've never seen one from a very high level. This slide is actually 5 years old, and I didn't update it because I'll show you what changes over 5 years. But basically, we do something like this in a data lake. We say we're going to do data ingestion. So we do the E and the L in ELT, so extract and load. So I extract from the source system, and I stick it in the data lake in an area I call the raw area of the data lake. And again, the raw area has all the dirty data, all the duplicated data, all the data that, as ETL developers and BI people, we hate, right? It's got null values, it's got timestamps in Unix format, all that kind of nasty stuff. We keep it there unaltered, okay? And again, avoid whatever you can doing transforms as the data's in flight. Because again, at some point, and I'm not going to belabor you, but I have an interesting story of how we took raw data coming in off of a source system and were able to detect fraud. And the company, it saved them a lot of money. But it's very interesting. Data scientists love raw data. So always keep that raw data. And I keep it in the area of the data lake, right? Now let's skip the stuff in the middle. What we do with this lakehouse model, which I'm a firm proponent of, where we say, do we really need the data warehouse, is we use the data lake as an area where we keep this enriched data. So the blue data, it's the data ready for user consumption is what it is. And user consumption could be simple real-time dashboards in Power BI. So if you use Power BI or Tableau, you can actually connect to a data lake. And you can query data directly in a data lake. It doesn't need to be in a data warehouse. So that's one thing. Data scientists, they can do machine learning against data at rest in a data lake. And then just looking out to the right here, I believe that icon is Excel and the other one's also Power BI. You can actually nowadays, you can connect Excel data and Power BI directly to your data lake, and you don't need a data warehouse. So again, I did this slide probably wasn't that long, 4 years ago, and you couldn't do that. That wasn't possible. So you had to say, take the lake data, put it into the warehouse, and then use the query tools that you want on top of that. It's gotten better. Okay, so now we don't need to necessarily have that data warehouse in the middle. I'm not suggesting rip out your data warehouse and throw it out. I'm not at all suggesting that. I'm just suggesting think differently about these processes. Anywhere where you can simplify a Visio is going to remove risk from a data project. Okay, so that's your enriched data. So raw data comes in, the other end, it comes out as enriched data, okay? What you do in the middle is the T in ELT, that's the transform, or the way I do it is I do it by sitting down and doing exploratory data analytics. So we're adding value to that data. So we're taking raw data, making it into knowledge, if you will, okay? And again, I like to call that sometimes exploratory data analysis or sandboxing. Much easier to do in a data lake than you can in a data warehouse. This is an old slide as well. People would always ask, why do I need to have a data lake if I already have a data warehouse? Or you could even make it vice versa. Why do I need a data warehouse if I have a data lake? Okay, I'm not going to read this stuff to you, but if you have any questions, let me know. okay? But essentially, I think the key things to understand is the data lake is going to allow me to do queries without getting all wrapped around the axle involving schema. This is a key thing, okay? So you can do data analytics without having to pull out all of the dirty data that came in the CSV files, for instance, okay? It supports a lot of data formats. I'm just gonna concentrate on 3 today, but you can get a lot. So those are the key things. But the key thing, the most key thing, I guess is the way to say it, is the schema thing. Okay, so let me just, you're all data professionals, and in the interest of time, I'm not going to have you take yourself off mute unless you really want to. Okay, but I'm just going to ask you some questions, and I want you to think. It's a thought exercise here. Okay. I mentioned at the very beginning, I was very transparent. I despise data warehouses, despise them with a passion. Why is that? Okay, again, if you haven't realized, I think you spend a lot of time doing data modeling on star schemas, and that's not necessary. At least it doesn't always have to be necessary. Let's put it that way, okay? But here's another thing. If you are a data scientist or you employ data scientists and you only have a data warehouse, data scientists struggle doing analytics against a data warehouse. They struggle. But here's the thing, most times they don't even know they're struggling, okay? It's just a struggle and they hate it and they can't figure out why. I'm gonna explain to you why real quickly here. Data scientists do things that would freak out the average data modeler, okay? Data scientists can only deal with tabular data where a given row is what is the level of prediction that I can do, and all the features that go into my algorithm. So the data that supports me finding the correlations are columns, okay? So in other words, let me say this differently here because I'm doing a bad job of explaining it. Data scientists, when they do a prediction, they can only look at the current row that they're making a prediction on. They can't look at the next row or the previous row. It's the way the algorithms work. Now, think about your average star schema. So your average star schema, right? You have facts and dims, okay? Think about the dimensions. Dimensions are generally structured as slowly changing dimension type 2, right? And for those of you, and probably everybody knows what this is, but just very quickly, you basically have a row, right? And it's the active row in the dimension table. And when some attributional data in that dimension changes, generally what we do with SCD type 2 is we say expire the current row. So put a date that says that this was my previous row, and also generally they tag it with the date that it's effective. Then they'll say, make a copy of that row, that becomes the active row without an expiration date, and then any attributional data that's changed, put that data there, okay? That's generally how we do SCD type 2. Now, imagine what I just described there. Every time I make a change, I have to add a new row, right? Data scientists can't use that. That structure is out of the question. So let's say a data scientist says to you, I think that we can predict something. Let's just say we can predict sales based on when a customer's address changes. Okay, so now they have to go in when a customer's address changes. What are you doing with SCD2? You're expiring the row and making a copy and making a copy and making a copy every time the attributional data changes. So when I look at data science or the data scientist code where they're doing analytics against a data warehouse, what I see is about 500 lines of code, and about 480 of those lines of code, so 90% of the code, give or take, is taking data and doing pivots on it. It's saying, take the data from the next row and make it a column. Take the data from the next row and make it a column. Data scientists have to have all the data that supports the prediction on individual columns. Now, data modelers are saying, wow, you just violated second normal form. Yep, you absolutely did. And that's what's required to do a prediction. So think of it this way. You have data coming in from an IoT sensor. Every 60 seconds, an IoT sensor sends in the current temperature. Okay, how would you model that as a data modeler in a database? You would probably, I would venture a guess, you would say, well, every time the sensor sends in new data, it becomes a row. Right? That's how you would do it. So every 60 seconds, I have a new row with the temperature. Okay, now you give that data to the data scientist and you say, I want you to predict, is this machine overheating, or is there going to be failure? The data scientist has to take all that data and pivot all of those calculations, those observations every 60 seconds, they need to make that a column. Think about what their structure looks like, okay? They have a row that is the sensor ID, okay? Then it's current temperature, current minus 60 seconds temperature, current minus 2 minutes, current minus 3 minutes, current minus 4 minutes. That is a super ugly structure, and data modelers freak out when they see that, but that's what's required. Now, you've probably got a ton of questions on how data scientists do that, and how many columns do we know we need? All right, let's not get in the weeds on that, but that's what they need. As we all know, as SQL people, doing pivot tables is horrible. We hate it. Or pivoting data using pivot and unpivot. That's what data scientists have to do. In a data lake, you don't have to do that because the data is structured on the time axis automatically. Okay. And again, I will show you this in a second, but just suspend disbelief. So data scientists can go in and they say, oh, I have all my data I need. It's already here. 500 lines of code becomes probably closer to 300 lines because there's still some work that has to be done. And the time to value, the time to insight for the data scientist is radically improved by using the data lake. So give a data warehouse to a data scientist, they will be unhappy. I guarantee you that. So you might need, as somebody just pointed out, you might need both. And that's the key thing, but that's where we do the evaluation phase. All right, so we're going to skip that here. If you've never seen a data lake is basically structured as a file system, and I'll show you some examples, but generally what you'll do is you'll have something like a zone called raw, a zone called curated, and a sandbox zone. And then the folder structures under that will be something like landing and raw, and we do differentiate these, and then usually people will do nowadays bronze, silver, and gold. What that connotes is as we go further down bronze, silver, and gold, we're going to have further aggregated and cleansed data. So bronze is a little bit dirty data, but it's meant for data scientists. Gold is, in most organizations, they'll say gold is my star schema, or it's my data that's ready to go into the data warehouse or into Power BI. That's generally what that means. And silver is just, whatever happens between bronze and gold. If I need to persist it for query purposes, I stick it in silver. So that's generally how it works, okay? And we're going to show you some examples here. Okay, so enough of this. Let me go up here and let's actually look at some stuff and actually get into fun stuff. Nobody wants to see PowerPoint. Let me go in here. I have to change what I'm sharing. 1 second. I think it's this one. All right. Yes, okay. Hopefully you should see, this is my Git repo that I mentioned at the beginning. This has all the code for the demos I'm going to show you, okay? So it's all out there. That's out there. I just want to go over a couple of things here. I do have a page out here in my repo that goes over, if data lakes are new to you, how to structure them, because you kind of get to get the structure like somewhat right at the beginning if you're going to do analytics that are meaningful. I see a lot of people that just build data lakes as a repository for CSV files that they're done loading and it's just archive. If that's all you're going to use your data lake for, that's not a data lake, that's an archive. But be that as it may, I have a lot of information here. There's a lot of stuff here. I don't want to get into the weeds in the interest of time, but there's paths to this data and I explain the pros and cons of various approaches out here. So it's stuff you can read on your own. What's bronze, silver, and gold? I have interesting things about file formats in here, if it's transactional or snapshot data, how we do permissioning for data governance, and how we do partitioning. All kinds of interesting stuff. All right, but let's not worry about that in the instant. Let's just go out and do it. So again, in my Git repo, I have instructions where it'll rebuild everything that I have here. But let me just show you this briefly here. This is what a data lake looks like. So this is one, and in my repo, I give you access to my data lake. It's just read access, I hope. So hopefully nobody can break it, but it'll look something like this. And you want to structure very intentionally your data lake such that it makes sense and it's self-documenting. Having said that, mine is what's known sometimes in the industry as a data swamp, which is an ungoverned data lake, but that's just because I'm lazy. But this is a data lake. This makes no sense the way it is. The data is just thrown in there. There's no zones, but do as I say, not as I do type of thing. Let me just show you how this works here. There is a data set that you can get freely available from New York City. It's called the taxi data, and basically it has data that's available in a data lake style format. I'll show you that in a second. that has, basically every taxi and ride sharing event going back, I don't know, it's like 10 years or something. I make a copy of that in my data lake, so I don't have to query theirs. And my data lake looks something like this. So notice the data is structured on the time axis automatically. So as the data is coming in, I build these folder structures. Okay. Notice I stopped loading the data 2017, but let me just go in here and show you this. And this is a common way to structure a data lake. Okay. So I have year data there. As you can see, and then under that I have month data. So notice again, I stopped loading this in June of 2017 because I have enough data. But if I take a look at this one, notice now I have this is a type. So if you're familiar with New York City taxis, there's green taxis, there's yellow taxis. I forget what FHV stands for, but it's basically Uber and Lyft. It's ride sharing. And then if I look in one of these like yellow, I see data for the month. And this is the file that actually New York City provides. Notice it's about 900 megabytes and it's just a CSV file. That's all it is. So it's no big deal. This is what a data lake is we have data and it tends to be loaded as to when the data is generated. So you can look at this data and say, well, this is just the trip data from May of 2017, and I have it structured in this data lake in folders. That's the key thing. You definitely want to have a data lake structured usually on the time dimension. So this is called time partitioning. Okay, if you're familiar with SQL Server, you know you can partition tables. That's what we're doing here. We're partitioning our tables, but by essentially splitting up the CSVs into folders. So that's the key thing with a data lake. So I just want to show you that. Let me go back here. I have a slightly different data lake that I'm going to show you. And I can never find it. It's this one. Okay. And I have multiple data lakes. And that's because what we find when we talk to customers is customers have multiple data lakes. Okay. And you may think, well, shouldn't you have a corporate data lake? Yep, you should. But the fact is we find sales teams have their data lakes, marketing people have their data lakes, product development have their data lakes, right? And if you think about it, it's the same reason why data marts are so popular, right? I have the corporate data warehouse, but the corporate data warehouse is not optimized for ancillary sales or marketing use cases. So I need my own. So it's very common to have multiple data lakes. And as part of that script, I actually build for you multiple data lakes because it's important concept. What we find right now, the biggest trend in the industry right now is something called data sharing. And data sharing is where I share my data potentially with other departments or even other business partners like vendors, supply chain partners, things like that. And I want to share that data. And, again, why did data projects take so long? ETL, right? And imagine if I had to never do ETL. I mean, never do it. Data sharing is getting away from ETL entirely. So imagine if I had my data lake here, and why is my data not coming up here? Where am I? Oh, there it is. Okay. Imagine if I just, instead of making you copy my data from my data lake to your data lake, what if I just shared this and I allowed you to do that? That's kind of where we're going in the future. It's called data sharing. Sometimes people call it data virtualization or data mesh, data fabric, but it's basically saying, I'm going to give you access to my data lake. Probably just as read-only, right? And now you don't have to do any ETL. You just connect to it and you're looking at my data. Okay, that's the interesting thing. Now, again, there's data privacy concerns, but put all that aside. This makes analytics with your data, with your partners in your business, just so much easier. I'm never doing ETL, right? Assuming that I can, utilize, the structure that my data vendor is providing to me. So it's a big if. Okay, but here you go. This data lake is structured a little bit nicer. I have a raw area, a silver area. There's the gold, there's the bronze. All of that kind of data is out there, and that's kind of what we're looking at essentially. So this is like a little bit better way to look at data. And then again, if I look at that, I have my different source systems here. And then if I go in and I look at this here, I have data structured a little bit differently, but you'll notice it all comes down. Eventually, I time partition the data. Okay, enough on all of that. Let's assume for this that we already have a data lake. So we could talk for hours and hours on how to set up a data lake and all that kind of stuff. I want to show you as SQL Server people how you query these things. So what you want to use is this thing called Synapse in Azure, okay? And in Synapse, we have, We've changed the name. It used to be SQL Data Warehouse, but again, data warehouses have that weird political connotation with executives. So we renamed it a while ago, not quite a year ago, to something called Synapse. The problem is we've become within Microsoft enamored with the term Synapse, and we call everything Synapse. So we have a Synapse this, a Synapse that, and a Synapse something else. Let me just describe to you what the Synapse thing is, okay? There's two pieces to Synapse. There's a workspace that has the SQL Data Warehouse, and it's an MPP style system, and I don't want to get into too much. You don't need that. For any of you that are using Synapse Dedicated is what that's called, and I have it broken down here as to which they are. You know that it's kind of an expensive thing because the billing model is this thing called DWs. It's meant for huge data warehouses, not 20 gigabyte data warehouses. I'm talking about big facts and dims. That's what it's meant for. But we're not going to use that. It's very expensive. We're going to use this thing called serverless SQL pools. And serverless SQL pools is I don't pay for the query until I execute the query. That's the beauty of this model. All right, but we'll come back to that in a second. Let's not get off on another tangent. It's meant for EDA, Exploratory Data Analytics, okay? And it builds what's called a logical data warehouse. You can use it for ELT or ETL. We can build stored procs that basically do data movement. It uses standard Transact SQL, and sometimes you'll see it documented as Synapse Serverless or Synapse On Demand. And basically, you don't pay for it unless you use it. So if you're not doing analytics and you're just sitting in sprint planning meetings, for the entire week, you're not actually getting charged for it. So I love it. It's an extremely inexpensive tool to use. Okay, so as long as your data sits in a data lake, you can use this serverless tool, and it's just standard SQL. And I'm going to show you all of that. So again, this is not Synapse Dedicated. Now, some of the things I'm going to show you can use Synapse Dedicated for, but not for exploratory data analytics. That's the key thing. Again, for the person that asked at the beginning, can we use something else other than Synapse? Yes. So what I'm showing you here, I actually have another repo. If you hit me up on LinkedIn, I'll show you how to do this. All of this stuff that's in this repo, I do also in Databricks, which is another tool I absolutely love. And then there's nothing stopping you, quite frankly. These are very common usage patterns, exploratory data analytics. You can do this stuff in AWS if you want as well. It's not really a problem, or Google Cloud or on-prem, okay? This Synapse SQL Serverless that we have here, just so a lot of people like to say, well, I don't kind of understand this technology. Give me an analogy, like what is this in the real world? This is basically SQL big data clusters, but it's in an on-demand thing. So if you've ever played with big data clusters, that's what we're doing here, okay? So that's what this is under the covers, but we do it in an on-demand manner that's very cost-effective. So that's what it is. The usage pattern here is we're running BI, or we're running analytics directly over the data lake without putting the data in a data warehouse. So generally you ingest data as either what's called Parquet files, or nowadays Delta is the thing, and Delta and Parquet are pretty much the same thing, so don't get wrapped around the axle, or CSVs. Those are the common ones. JSON also is quite common. Okay, once we have that data in our data lake, we can use, so it's landed, we call that. Now we can start using Synapse Serverless to actually do the analytics. And these are ad hoc queries, essentially. So that's what we're doing. And I don't want to go over the rest of that because it's all on Synapse Dedicated. So I'm in my Synapse Studio here. Let me launch that. And again, I have instructions on how to set one of these up. This Synapse Studio thing costs nothing. It costs nothing. Well, it's like $1 or $2 a month because there's some settings that are saved in a storage account. So there is a slight charge, but it's not expensive. Okay, so you can redo this in your, like in your environment at work, or if you have an MSDN subscription or something, you can do that. Not a problem. Okay, and what I'm going to show you is the Synapse Serverless option. So let me show you that here. That's under here called this thing called SQL Pools. Okay, and in SQL Pools we have different types. Dedicated is kind of the the massively large data warehouse option that we have, meant for big facts and dims. That's not what we're going to do. I don't know why that says that's not running. That scares me. Murphy's Law says this demo won't work. Hopefully that's just a temporary thing. And then you get this one thing called serverless, which is a built-in, and you don't have to even manage it. There's nothing you have to change or do to it. It just kind of runs, but it only runs when you want it to run. That's the key thing. So that really scares me right now. But anyway, it's extremely inexpensive. I can't quote the exact price, but it's based on how much data you're extracting or egressing out of your data lake per query. But it's very cheap, especially for the use cases that it's good at. Okay, so here's what it is. What I'm going to show you next is something I've never seen any other tooling in the industry that does what this does. And I love this. And within Microsoft, I'm begging and pleading that we market this tool a lot better. This is what I call the Visual Data Lake Explorer. So I have multiple data lakes here, and you'll probably recognize this one if you were paying attention a few minutes ago. This is my kind of data swamp here, but I can look at my data swamp here and I can see, well, let me just go down and show you the other one. This is the data I showed you previously. So there's my reference data, my transactional data, okay? Here's my data for years. If I go in here, if you remember, I partition it by month, it's partitioned by type, and there's my CSV. And what I'm going to show you here is, notice I can right click it just like in Management Studio. I can right click a table, or in this case, a CSV, and I can say, show me the top 100 rows. Whoa, I'm doing queries on CSVs without loading them into SQL tables. That's a powerful thing, and I'm doing it all graphically, right? I'm finding the data I need by clicking around, and then I'm right clicking and I see my data. Okay, so that's there's one data lake that I have. I have two other data lakes. And again, I show this because every organization has multiple data lakes. It's the kind of the nature of the beast. Here's another data lake I showed you. If you remember, I had you in my lake area. So there's my lake. If you remember, it's bronze, silver, gold, curated, all that kind of stuff. I could go through here and I can look at my data there. And again, now these are big data lakes, those two, so I don't reproduce those as part of my scripts, but I do reproduce this one. Okay, so this is my demo data lake that I use for this, and if you're wondering what WWI is, it's worldwide importers. Okay, and again, my script will reproduce this data lake for you. Takes about 10 minutes to do in your environment, or I also give you the connection information to do data sharing, so you can actually look at my data in your Synapse workspace. By just looking and connecting as read-only. So you can do that as well. And again, it's a great way to get data done quickly. Okay, so I just want to show you now how we do the SQL queries, right? So finally, we have 20 minutes left today, and we're actually going to write some code. So if I go in here, here's my sales small, and it's an abbreviated data set, so I don't have all the years in here, okay? But if I look at 2019, last year, notice here I partition a little bit differently. I partition the data by quarters, and then by months, right? And then by days, and notice I changed the paradigm a little bit. Now I actually do YYYMMDD. There's a reason for that, but again, don't get around the axle too much. And here, this is a Parquet file, and it's actually a snappy Parquet file. And you're probably thinking, I have no idea what that means. Okay, a Parquet file is just an optimized storage structure, but it is a flat file, but it's optimized for analytics. So CSV files have no schema. Parquet files have very good schemas, okay? Nowadays, Parquet is kind of going the way of the dodo, and people are using Delta tables, it's called. There's really not that much of a difference. So I have Parquet. Someday I'll update this to Delta tables, doesn't matter. Here I'm gonna say new SQL script, select top 100 rows. And what does this do? It writes, and you're gonna have to forgive me, there's something wrong with my browser here. This is, okay, there it is. Sometimes I have a problem getting all of it on the screen here. You'll see in a second as I start to get frustrated, but it writes this query for you, okay? So the query says, I wanna see select top 100 star from, and if you're familiar with SQL Server, it has open row set, and here is my connection to my file. And I always tell people when they're doing analytics, don't do analytics on a huge table that has years and years of data. Just use a small subset, right? Keep it simple. So I just want to look at data for this small subset, which again would be December 1st. Okay. Now, when I take this, it says, how do I want to run this? I'm going to say use my built-in. If you remember, that's called Synapse serverless. Basically, it's a pay by query. You don't shut it down. It's not generating anything until you hit the run button. So I'm going to hit the run button. And what this is under the covers is SQL Big Data Cluster running in containers. So it only spins up the containers as needed. And then it waits about 15 minutes or so and spins them back down. Okay. Now, when you run queries using Synapse serverless, don't expect it to be wicked fast. That's not the use case. And since it's Docker containers, you can pretty much assume there's a cold start problem. Okay, the cold start meaning the first time I use the container, it's going to come as though the SQL Server just rebooted, and it's going to take 17 seconds to do the query. Not uncommon. If I rerun this, the cold start problem goes away. It'll probably come back pretty quickly. Okay. Now, again, if you're looking for sub-second response times, you're not going to get it with this tool. That's not its point. Its point is to do exploratory data analytics. So we're going to do interesting things with data, and we're not too concerned about getting fast results. Now that executed pretty quickly. Okay, notice I can chart this data here, okay, because it's almost like it's a Jupyter notebook-like environment. And here's my data, okay? So I get to see all of my data and what my schema looks like right there. Okay, now nobody wants me to write queries, so I'm going to show you some. I have queries out there that are pre-written. I'll show you those. Notice this is just transact SQL. Okay, that's all it is. Okay, so anything you do in transact SQL, you can do here, or just about anything, I should say. There's probably exceptions, but I can do joins, group bys, I can build derived tables, I can do, did I already say joins? I can do correlated subqueries, whatever you want, it all works, okay? Again, there's probably edge cases that don't, but that's the key thing. All right, let me show you the queries I have, and they're in my repo. I have this little thing called Exploratory Data Analytics, and let me bring this up here. Okay, it's just a SQL script. By the way, I'm using the browser-based Synapse workspace to do this. You don't have to. This is a SQL server under the covers. Okay, it has an endpoint, and you can use Azure Data Studio to do all of everything I'm showing you. I just use this. It's because it's easier for me. But you know, the hardcore developers on the phone are like, man, I don't do browser-based development. I agree. So you can use Data Studio. It's just I'm not doing it. Okay, so what I do a lot of times is I build a database to put all of my code. Let me just show you this real quick. We'll take a quick tangent. My databases here, I have 4 of them, okay? And this is what, so I have one out here for Spark. Nobody cares about Spark, but I have these. So I have one out here, and I can tell this is a dedicated SQL pool. How can I tell? It has tables, okay? So in other words, this is the old SQL data warehouse that we had. But if I look at this one, oh, well, that's weird. It's gone. All right, never mind. There should be, and I don't know why I have, it looks like, well, see, I lend my demo environment out to people and they mess with it. There should be a database out here called Sandbox, and I don't see it out there now, but Sandbox is basically what I use. Yeah, it's not out there. And of course I don't have it here, but it's what I use essentially to do my demos. And what it is it's this notion of a Synapse serverless database. And Synapse serverless has no notion of tables. It's all external tables, okay? There's no native storage. It's just a compute engine to run queries over a data lake. That's all it is. And this is not the example file I wanted. Let me go back and find the other one. It is, again, I think people mess with my environment. That's why I should never share. Okay, here it is. So here I have a sandbox. Well, there it looks like Sandbox is up. That's kind of weird. So these, let me just go back here. I think somebody was in there. Nope, I don't see it out here. Okay, sorry about that. I should have practiced this morning to make sure nobody messed with anything. Let me just run through a couple of queries and show you what I'm doing here. So this query, again, I got by right-clicking the data in the Visual Explorer and saying select top 100. If you remember, it was for the data in 2019-012-01, okay? So that's a basic select star. All I do in this query, you're just going to have to trust me, is to do a select count star just to show how many rows that this is querying. And it's querying about 371,000. So this is not big, you know, and again, it's not running real fast either. I'll just be honest with you, but that's not the use case. That's the thing. Okay, so let me show you the next thing here. So again, I can do joins, group bys. I think you get the idea, right? I want to change this around a little bit. And I want to say, okay, but this query is only looking at 1 day's worth of data. So you can connote that for December 1st, 2019, we did in sales, 371,000 sales, and you'd be right. That's how the data lake is structured. So it's almost self-documenting, but who cares? Let's say I want to see all the data for 2018. How would I do that? Okay, here's how you do it. Okay, I'm going to change my query around a little bit, but notice what I did here is I said, here's my path, and I put stars out here. And if you're familiar with DOS, you can do star.star. It's the same concept. So I want to say, I want to see all the data for years 2018, right? And now I say, look at the path up here to compare. I want to see it for any quarter. I want to see it for any month. I want to see it for any day, and I want to see any file. And that's all it's doing. Now watch what happens when I execute this. And again, my browser's not cooperating. It never does. When I run this, it should only take a few seconds. Again, it's not wicked fast, okay? It's not like you're using SQL Server natively. We're doing this against text files, remember that. But this should come back, and if I remember correctly, it's 300 million, and yeah, it looks like 327 million, something like that. Yeah, 327 million. So again, not wicked fast. It took 16 seconds. But if I'm sitting next to a business analyst, I don't care if it takes a couple extra seconds. That query probably only cost me a few cents to run. And that's fast enough, quite frankly. All right, so we'll leave it at that. All right, I think you get the idea. Here, I take the data and let's change the paradigm. I say, I just want to see, so let's start up here. I want to see by date what the sum and the average profit is for just Q4 2018. That's it. So I do my group by and my order by. I look at this, and again, it's going to take some time here, especially when I do demos live, but it's going to get you the data back. Okay, this paradigm that I'm doing, where I'm doing queries directly off of the lake, how I've done this here. So again, it took about 12 seconds. This is pretty good, and this will get most users where they need to go. This sometimes complicates people, this from OpenRow. Business analysts, sometimes they freak out. So my advice is, depending on the persona, allow them to go through and use the Visual Explorer to find the data they want. And then remember, they can go in here and right click, and they can say, select top 100. For folks that maybe aren't that savvy with data lakes, don't give them that, just build a view. Okay, so this supports building of views. So I can build a view here. Here's a view. I called it sales 2018 Q4. It's the exact same query as above, right? It's just I'm making it a view construct. That's it, which now, look at that. That looks just like a SQL Server table. If I give views over a data lake, no column called transaction date, and that's because I spelled transaction date wrong. It's case sensitive. There we go. Let's do it that way. You can change that setting. It's just I never bothered. At this point now, just take a look at what I've done here. I'm basically making data in flat files look like SQL tables to analysts. This is awesome, right? And I've never loaded it into a table. So anyway, there's that, okay? Let me show you a couple other interesting things here. So this is an interesting query I'll show you here. Let me just start by showing you this, okay? So here I say, I want to look at data. So I'm going to eventually build a view called sales 2018. You get it. But here, the first thing in green that I have commented, that's where I went through the Explorer. I right clicked and I said, select top 100 on a row or on a file rather. And I looked at December 3rd. Okay. Now I changed the paradigm a little bit. Okay. And I say here, I want to do how CSV files work faster without indexes. That's the beauty. We'll cover that in a second. Hold that thought. Okay, so here I say I want to create a view that's just 2018. I don't care about the quarter. I don't care about the month. I don't care about the day. And I don't care about the file. Watch what I do. Okay, up here we have metadata. So I call my derived table result. So I have columns I'm adding called result dot. You get the idea. Standard SQL Server aliasing coming up here. We have metadata called the file name. So this is going to tell me when I run this, what file does a piece of data come out? When do you use something like this? Okay, if you've got dirty data and the data's throwing errors or something like that, I can say, where is this data coming from? Because I want to see the dirty data or the bad data. That'll give me the file name. This one will give me the entire path of where that data comes from. I'll show you that in a second. What does this do? So here I take file path and I add 1, 2, and 3. Okay, it's the ordinal position of the asterisks or the wildcards, the ordinal position, and it's one-based indexing. So unlike everything else, it's one-based. So here this says the quarter is the first star. Okay, the month is the second star. The day is the third star, and I don't care at all about the file name, which would be the fourth. Okay, when I do this, let me show you what this looks like. I already built the view out there. Let me show you what this looks like. I just want to bring 10 rows back. And again, remember, it's doing this just for 2018. Okay, so this shows me all my raw data. Now, if you remember, I had a column that I added up above called the source file name. That's where the data comes from. So if I'm looking at a piece of data and I say, that looks weird, there's something wrong with my data lake, that'll help me. This gives me the full path. That'll help me there. Now look at what this does. This gives me the quarter, the month, and the day of where that data is coming from. So notice I said, there's the name of its quarter, right? And I say quarter equals star here. And if you remember my folder structures, let me just go back. My folder structures were quarter equals Q4, okay? And month equals 10 and day. Let me go back to here. Apologies, I'm flipping around like a mad person. And you're probably getting dizzy. That's not my script. Where's my script? This one? I lost my script. It is it this one? It's this one. Okay, sorry about that. So here I'm saying my quarter is, let me scroll back over, Q1. So there's my folder name, my file name, my month is 1, and my day is the YYYMMDD, right? Awesome. Now watch what I can do with this, okay? I can say, let's skip some of this. I can say, just show me data from Q2, okay? When I say just show me data from Q2, this does what's called predicate pushdown, and it's really fast. Again, it's not meant to be really fast, but the net effect is it's really fast. What is SQL Server and Synapse doing under the covers? When I issue this query, I'm saying, just show me Q2. Well, the optimizer looks at this and say, well, you're only looking at 2018 already. So really what I want to look at is 2018 Q2. And now it can look at my data lake at just a subset of the files that I want to look at. It doesn't have to look at every file. And that's the beauty of data lakes, is generally doing queries off text files would be a horrible performance hit, but we can do these tricks with predicate pushdown and really make things super fast. So here's another one. I'm not going to run these. I think you all get it. This is going to do predicate pushdown, say, just show me what's in month 12, or just show me what's in that day. And it doesn't have to do all those scans. That's the beauty of this system. Okay. Now I'm querying Parquet files. So somebody asked, how can this work faster without indexes? Parquet doesn't require indexes. CSV files, again, they're going to be slower than Parquet. Parquet is an optimized file format for analytics. But here's how I do CSVs. Let me show you CSVs real quick. If I go back here and I find I have customer data, and it sits in a CSV. It's very small, it's just 10K. But if I right click, I say select top 100 rows, it generates this kind of shell of a query here. If there's my customer info.csv, I hit the run button here and it comes back. It's very small. It comes back very fast, but it's because it's a tiny file. But notice it didn't do it right? So you can look at this right away and you know that it's just doing column 1, column 2, and the first row has the headers. So again, when I do this, and I'm doing exploratory data analytics with a customer, I don't know what their data lake looks like. I don't know if they do CSV files that have headers or not. This is how I do it. I look really quickly and I say, oh, well, that's what the data looks like by right clicking, right? Now I say I can basically fix that data. So here I apply schema to that CSV file. Why do I not have that CSV? Well, okay, I have product data, but I think I did customer as the example. Sorry, but here's how I do, just in the interest of time, here's how I apply schema to a CSV file so it looks better. So again, I use this open row set. I say the first row, skip the first row, and then I say, here's the schema. So that would be if I have a header. And if I look at this again, I know I did customer before, but just in the interest of time, now this looks a lot better, as you can see. Okay, so that's how I do that. Again, I would not want the average business analyst to have to do this work, right? It might be too much. So what's the trick? Give them a view. Do a create view, they're off and running, okay? Here's JSON data. I'll show you this real quickly. You can also use JSON, which is a very common format. I think I have it out here. So I have product data. Oh, nope, that was the one I was supposed to do. That's the product data. Oh, here it is, product JSON data. So here's the JSON data. It sits in a folder structure. Notice there's 5 JSON files out here. If I just do a preview on this, you'll see that it just has 1 row per JSON file. That's all it is. So if I go out here and I say right click and I do new SQL script select top 100, it's only going to show 1 as we know, but just to show you what this looks like, again, I'm just figuring out what is in this file, right? So I look at it and I'm like, oof, Synapse did a bad job doing this, right? Because it just gave me flat JSON. I would like to see that in a columnar format. Okay, well, here's what you do. There's a trick to doing that as well. And if I go in here, that's not my script, it is this one. I can do, this is all well documented, but basically if you've ever seen cross apply, I can do the open JSON command, give it a schema, and now I can look at this data. And let me just do this very quickly. When I look at this data, I see my 5 rows, which basically, if you remember, each JSON file had a single row, but there's my data. Again, I can put a view over top of this and I'm off and running. Okay, last thing I want to show you, and actually I'm not going to do anything else. I have a lot more out in the repo. There's a lot of cool stuff you can do with this, but this is data lakes. Okay, this is replacing or considering doing star schemas in your data lake instead of necessarily doing them in a data warehouse. So I'm not advocating at all that people wipe out their data lake or get rid of their data lake or move to the lakehouse paradigm or use data lakes entirely. It's just a way to think quickly about data without necessarily having to apply schema. So if anybody has any questions or anything, because we'll let the next speaker come in, I'm happy to do that. Hit me up on LinkedIn. When you do the feedback for the GroupBy event, if there's anything I should do differently, let me know. If you want to see, additional demos or have me work with your company, feel free to do that. So I'll leave it at that.
Thank you, Dave. Amazing session.